everyone, this is Paul Nishihira with GoEngineer, and welcome to another quick tips video. In this session, we're going to talk about chamfer machining inside of CAMWorks 2016. We will talk about what is chamfer machining, what's new for 2016, model application with programming examples using SolidWorks and CAMWorks. So, what is chamfer machining? Chamfer machining is an option available in contour mill operation. This option allows the user to machine a bevel or edge break of a specific numerical value using dedicated tooling on the top of a feature with a tapered tool. This tool can be a dedicated chamfer tool, a countersink tool, or a tapered end mill. Other unique features and functions include chamfer machining can be used on sharp or square edges. Although the display will update visually when using Simulate Toolpath, it does not affect the SolidWorks feature. Parameters are specified by angle. This parameter is for reference only and reflects the taper angle of the tool. The chamfer angle is defined as the angle between the top face of the feature and the side of the chamfer. 0 degrees is parallel to the XY plane, and 90 degrees is vertical. Length specifies the horizontal distance between the vertical side of the feature and where the chamfer meets the top face of the feature. Clearance. This parameter controls the machining depth, that is, how far below the bottom of the chamfer the tool goes. If set to 0, the Z value of the tip of the tool will be equal to the bottom of the chamfer. If set to a positive value, the tip of the tool will extend below the bottom of the chamfer. If negative, the tip of the tool will be above the bottom of the chamfer. Feature edge. This parameter defines whether the geometry in the feature is to the apex of the chamfer or to the outer edge of the chamfer. Depending on the condition, the resulting toolpath will be offset in XY by an additional amount equal to the chamfer length. The two geometry conditions are shown to the right. CAMWorks 2016, what's new? Includes improved user feedback regarding maximum chamfer length achieved on blind and through feature types. Warning message displays if machining length exceeds specific numeric value. Clearance amount will reset to maximum possible value based on tool diameter, chamfer length, and feature depth. Negative clearance values are not allowed. Tool depth can be larger than the feature depth for through features. Next, let's take a look at our SolidWorks model and some programming examples using CAMWorks. Over in our SolidWorks model, you can see that I've already assigned a work coordinate system. And regarding chamfer feature types, we have several exterior sharp edges, some internal sharp edges, as well as exterior chamfer features, and internal features as well. I've already taken the liberty to remove as much material as possible so that we can focus on chamfer machining. If I simulate my part, this is what we have. Let's go ahead and run through a couple of examples for chamfer machining. The first type of chamfer machining that I'm going to focus on is this edge break. Over in the CAMWorks feature tree, I currently have this rectangular pocket 1 strategy, and I'm going to go ahead and reuse that and apply my chamfer machining operation. I'll go to my CAMWorks operation tree. We'll create a simple contour mill. Select my 2.5 axis feature. Hit OK. And at this point, we're just going to use our standard TechDB defaults. Click OK one more time. And now it's a matter of going to our tool crib, and we'll go ahead and utilize the 1/4 inch countersink for this operation. Over on the Contour tab, we have a checkbox for chamfer machining. Let's go ahead and see what it does. So right now, we'll leave our length at 0. We'll have our clearance set to 25 thousandths, and we'll drive the feature edge from the apex of the part. If you would like to make changes, it's a matter of expanding this drop-down arrow, and you can either choose outer edge as well. Let's take a preview and see what happens. Based upon the current numeric values that we have, CAMWorks is going to give us a message saying chamfer length is not valid. So let's make a couple of changes. We'll click on OK. And then our length, we'll type in 15 thousandths. And then preview. Let's take a detailed look and see what's happening. If we backplot our toolpath, we can physically see what's happening with our chamfer tool based upon the current numeric settings. If we wanted to make some slight changes to our length, maybe we wanted a smaller edge break, we'll set it to 5 thousandths, and let's see what it looks like. There may be times where we need to make adjustments to the clearance. Perhaps the end point of the tool is worn and we wanted to use the upper portion of our tool to machine our chamfer. We can make changes accordingly. Click on Preview. Run a backplot. Our chamfer depth is deeper, but we're still maintaining the same value for our edge break. I'm currently happy with these settings, so let's hit OK. What I would like to do next is take this same operation parameter and apply it on the exterior portion of my part. Because I don't have a current strategy for that profile, I'm going to go ahead and create one. Let's do a simple boss. And our end condition will go up to face. And now we have this irregular boss 3 machine strategy. We will create another contour operation. Select irregular boss 3. But because we've already created that internal edge break, we're going to copy it from Contour Mill 13. Click OK. We can verify that we are using the same tool. We can also verify that we have the same chamfer machining parameters. Click on Preview. And if needed, backplot. Looks great. And we'll click on OK to accept. As I mentioned earlier in the PowerPoint presentation, we are able to provide toolpath simulation and have the model update accordingly with our chamfer machining operations. However, it will not affect the SolidWorks feature. Let's take a look. And as you can see in detail, we have our internal edge break at 5 thousandths by 45 degrees, as well as our external edge break, again 5 thousandths by 45 degrees. If we want to show the difference, we can click on this button as well. Looks great. And now that we are back in our SolidWorks model, you can see that our model feature still maintains its original geometry. In this next example, we are going to address this exterior chamfer feature. Our current values is set to 45 degrees by 50 thousandths. Let's go ahead and keep that number in mind. I did take the liberty to create an irregular boss 2 machining strategy. I'll generate an operation plan. And now let's make some changes to this contour mill 17 operation. We'll update our tool to the countersink. We'll go to the Contour tab and activate our Chamfer Machining checkbox. And with our current values, let's go ahead and we're going to set this to 50 thousandths. If you notice that we do have this CAMWorks warning message indicating that the chamfer length and or clearance exceeds the machining depth of 50 thousandths. We'll click on OK. As you can see, CAMWorks went ahead and readjusted our length. Let's see what we have. Looks like we need to make a couple changes. One change that we can make is adjust our clearance to 0 and the length back to 50 thousandths. Click on Preview, Backplot. As you can see, our chamfer tool follows the chamfer feature, but it's terminating right at the end point, which is not good machining best practices. Let's go ahead and make an adjustment. This time, I'm going to go to the Feature Options tab, and we're going to override our depth, and we'll make it to 75 thousandths. We'll come back over to our Contour tab. We'll still maintain our 50 thousandths length, but since we have that additional 25 thousandths, which equals the total sum of 75 thousandths, I'll go ahead and put 20 thousandths clearance. Let's click on Preview, Backplot, and we'll step through it. Much better. Once we're happy with our settings, we'll click on OK, and we'll even simulate toolpath again. We'll do a quick show difference. Looks great. In this next chamfer machining example, I'm going to address this through pocket feature. If we click on the chamfer feature, we have the values of 30 thousandths by 45 degrees. When we go over to the CAMWorks feature tree, we have this rectangular pocket 2 machining strategy, and I'm going to go ahead and use that. Take note that it does go all the way to the bottom of the part. We'll come back over to our CAMWorks operation tree, create a new 2.5 axis mill operation. Select our rectangular pocket 2. Click on OK. And for this one, we're going to use the standard TechDB defaults. We'll select our tool. Select the Contour tab, Chamfer Machining. We know that our chamfer is 30 thousandths. And clearance, we'll go ahead and leave it at the 25 thousandths for right now. We'll click on Preview. Let's take a detailed view of this. Let's take a detailed view of this machining operation. And we'll backplot it as well. Looks great. Since we have a through feature, we can actually make adjustments to the depth. Let's go back to our parameters page. And for the clearance, we'll set it to 150 thousandths. It'll reset to 95 thousandths. We'll click on Preview. And we'll backplot. Looks great. But if you notice, we're at the apex where the OD of the tool meets the angle of the chamfer. So let's make some minor adjustments. Let's decrease the size to 80 thousandths. Click on Preview again. Backplot. Much better. Next, we'll go ahead and run toolpath simulation. And finally, we'll show difference. Looks good. In this last example, we're going to address the blind pocket feature on the backside of this model. Let's go ahead and take a look. For viewing of better toolpath simulation, I went ahead and created this rough mill and contour mill operation already. If we go to the CAMWorks feature tree, it's tied to this odd brown pocket too. So let's go ahead and create a chamfer feature. Before we do that, let's take note that this chamfer feature is 30 thousandths by 45 degrees. Again, we'll go ahead and insert our 2.5 axis mill operation, contour mill, select our feature, click on OK, and we're going to use the TechDB defaults. We'll select our tool, go to the tool crib, and this time we're going to be using a 3/8 diameter by 90 degree countersink. We'll update our holder, select the contour tab, and we'll activate chamfer machining. As a side note, down in the lower right portion of the operation parameters page is a help button. Let's see what this is about. This will activate the CAMWorks Help Topics menu, and at this point, if we wanted to find out everything about chamfer machining, it's a matter of selecting the subject. And we have this great resource of information on chamfer machining. Let's close this out. Now that we are back to our chamfer machining options, we know that our length is going to be at 30 thousandths, and we'll leave the default clearance to 25 thousandths. One thing to take note, we'll go to the Feature Options tab, and our pocket is 150 thousandths deep. Let's just keep that in mind. Let's click on Preview, Backplot, and we'll take a look at our toolpath and see what it does. Looks good. Let's go back to the Operation Parameters page and make some minor adjustments. As mentioned earlier, this is a blind pocket. If we were to change our clearance value to something a little bit larger, perhaps 150 thousandths, because of our feature geometry and our current settings for our operation parameters, CAMWorks is going to give us a message indicating that we have exceeded the machining depth. We'll click on OK, and it will actually update our clearance value back to 0.12. This numeric value plus this is going to equal the 150 thousandths over on the Feature Options tab. We'll click on Preview, Backplot, As you can see, CAMWorks had prevented the tool from going any deeper than what the feature allows. Let's go ahead and make some minor adjustments again. We'll change our clearance to 20 thousandths. Click on Preview, Backplot, and it looks great. Let's click on OK to accept our toolpath, and we'll turn off our section view and go back into our second operation view, and we'll simulate toolpath for our final machining. Looks great. In summary, the CAMWorks Chamfer Machining options allows you robust tools to achieve the desired results that you want. This is Paul Nishihira with GoEngineer. Thanks for